Mm-hmm. Yeah, just 1 second.
Yeah, we see everything. That is fine.
Mm-hmm. So, yeah, currently the world of our technology is growing fast, and our all-based tasks are becoming more complicated. That they require more resources for any completion. And so in the result, we have multithreading, which is coming to help us with that situation, as it allows us for the efficient use of computer resources, and it's needed for developing high performance and reliable applications. My name is Valerii. I'm a software developer. Recently, I joined a new company, a startup, Boko Labs, and we are building the efficient trading engine now, and probably we will blow up the market soon. Previously, I worked also in 2 other companies. The first one was BostonGene. We have been creating a platform for doctors that provides personalized reports with the treatment recommendations for doctor, which is based on genetic analysis of each patient. So it was able to find different treatments which is related to certain patient and to find the most efficient one. Also, that platform required a lot of computations, and we developed a service for provisioning and maintaining cloud resources for any further genomic data analysis and calculations. So it was about more than hundreds of different instances in Amazon Web Cloud and Rackspace, just computing different results. After that, I have been working on Revolut for 4 years. We built a fancy trading desk. We worked a lot on some performance issues and developed a lot of services from the scratch. Starting from risk engine and different robots, sending some requests to order management system and some integrations with banks for providing some rates and different data related to orders. And in the end of my work in Revolut, we were working on the entire retail platform improvement. It was related to the whole department, and we tried to improve the entire life of our developers better. And yeah, currently I can say that I have some experience in the development of some high performance systems. So our topic for today is about multithreading, and especially it's related to its implementation in Java. In this workshop presentation, I will present you the most useful approaches from the Java core library, nothing outside it. That's a small note about it. And also it will be like a practical guide. So I also prepared a small task for you. And yeah, let's dive into it. Okay, nowadays all people care about their well-being. So the wealth plays a crucial role in securing our future. And individuals are constantly looking for the best investment opportunities. And I would like to suggest you to work with the current practical task, which is about providing an opportunity to buy or sell different assets at the most favorable price available. To achieve this, we have multiple providers. We can name it banks that supply us with the current rate of various assets. Each bank may have different rates at the same moment. So we can get an assumption that we can provide our users the best rate in the market each moment. Yeah, and then user can trade certain assets by this rate. Given that our requests to the platforms are blocking, and we should wait for their response to provide these rates, for instance, to our users, it's imperative to execute them in parallel to reduce the total time for collecting all the rates. And this is really important because the final response time will be really diminished, and each response time to each on each request to different venues, banks, can vary depending on the location of each bank, and time for round trip for each request, which is depending on our location related to the services, to the servers. So in this task, we will explore different techniques for implementation of parallel algorithms, which is related to parallel execution with Java core library. And before we delve into multi-threading techniques, let's check some prepared code that works in sequential mode. This will provide us with some baseline, which we can use for any further improvements and going through the steps in the multi-threading world. So let's move to my repository. Okay, what do we have right now? We have rate provider. It's an interface, so we can find a lot of different implementations which are hiding some details of integration with different banks. It can be different connections or no matter. So the main purpose of this rate provider is just to provide our rate. So we request some rate for certain symbol like GBP/USD, for instance, as we are in London right now, and we will get a rate, or some exception or any other problem. And we have one point, which is entry point. So each request from user, let's imagine it's coming from some endpoints, but we would say we just implementing some services which is collecting data and returning it. So we have rate service, which is collecting some data from provided rate providers. It will execute it in sequential mode. And then we check that we got at least one rate, and then we can choose the best rate, like the best task, the best bit, and we can return a new generated rate based on our all integrations. Yeah, and now we are going to dive into a parallel load. So what's about multi-threaded programs? There are two main concepts related to multi-threaded programs. The first one is concurrency, and the second one is parallelism. The concurrency means that our application runs multiple tasks similarly at the same time in no specific order. And these tasks are executed in a time-shared manner on a single processor. So it gives us the illusion of running simultaneously, even if they are executed one at a time. When our app frequently handles a request that block its progress, using concurrency can be highly efficient. As it helps us to enable another thread to be utilized while the first thread, which is currently blocked, awaiting for their response. Another paradigm is a parallel execution, which is on the chart on the right side. Parallel execution refers to the simultaneous execution of multiple tasks on a hardware with multiple computing resources, such as multi-core processors. Parallel execution helps to achieve faster computation and improve the entire system performance as well. And also, I would say we should define another term, which is about the second word from the name of our current slide, which is parallelism. This means that our application splits different tasks up into smaller subtasks and then can execute it in parallel. For example, on multiple CPUs at the same moment. So it will not be blocked, and we don't have any shared processor time. So they will be executed on different processors at the same time in parallel. And true parallelism is achieved when each thread runs on a separate CPUs, like on this picture, without any interruptions between them. Yeah. And so then we are going to our current situation in the real world. We are not able to imagine a lot of cores in different servers. So we are limited in this number, and it's not possible to run all tasks with a true parallelism. So this is where the concept of parallel concurrent execution, like a combination of parallelism and concurrent execution, coming into play. Yeah, in parallel concurrent execution, multiple threads are distributed across multiple CPUs in a multi-core processor. So we can find some distribution of sets of threads coming to the same CPU, and they will be executed in a concurrent way. But all threads from different CPUs will be executed in a parallel. Yeah, this diagram just shows us how multiple threads are distributed across different CPUs, and that we can find some way to execute different threads with some interruption and switching processor time between them on the single one. And this approach allows for efficient use of the available resources and really can improve the overall performance of the system. And yeah, the first approach in Java to make our code execute in parallel, it's a base concept of thread in Java. We can imagine that thread is a like virtual CPU, which can execute our code inside an application. When Java application is started, it will be started from main method, which is started by main thread. And yeah, which is created for running your application by the JVM. But inside your app, we can run many other threads. For instance, we can schedule some things, or we can directly call any other thread from our main method. And yeah, only part of them will be executed in parallel, as it depends on the processor of the system, as we have a limitation of on the number of cores. And while we have some executing in parallel, others will be in the waiting state, just waiting for a time for their task execution. A thread represents a system thread, like a process in an operational system. And threads are scheduled and have a life cycle. When an application has a few threads executing on one CPU, the system will be switching between them, as I already said before. So the system just say what is the time period for each thread to be executed each time. And yeah, when the system switching between different threads, it should save some data about the previous one and load the next one. It's about like own stack, program counter, and any other related stuff. So it's still about some costs of time for our program. And this switch between threads and saving and loading a new thread context, we can name as a context switch. So in the result, we should be careful with the final number of created threads, as it can result to the entire app performance slowing down. Okay, we got a small understanding of threads in Java, and yeah, let's try to use them to parallel our program. Okay. Firstly, I would show you how I improved our code. Yeah, as we had some implementation in a sequential mode, we should improve it, but I want to save all the previous implementations. So I introduced one more thing, which is named rates collector. It works with the symbol for which we should provide the rate. And we can find providers from which we should provide these rates. And in the result, this interface should collect some rates from different providers and return all of them. And rate service will use the same approach, like choose the best ask and bid prices and return it to the user.
Can we make the font a bit bigger? That's from our chat.
Do you know how to do that? Yeah, probably
Zoom in on our side, it's not too bad. You won't be able to do it.
That's not it.
You can zoom in with Zoom.
Okay. Yeah, sorry, I don't see it. Okay, yeah, as I said, we have rates collector. Also, we have a base rate service test, which is just checking that we set up our providers, and collector works with them and collects the best rate we set up it. And also we have sequential, our sequential implementation, which is hidden in sequential rates collector. So it's just the same logic which we had before. And we also have a test for it. So just checking that rates will be collected, and even if we have any slow answering platform bank, we will collect all the data and we'll return it to the user. So let's dive into thread implementation. Let's create another, sorry, just a second. Let's create another behavior. And we will name it by thread rates collector. So what we should do here, we should create a thread and use it. We have a base class thread in Java that can be created just an object, or we can create, we can run our code like just an object thread, and we should put there some runnable interface, or we can just implement thread and put override run method and provide any logic there. We can execute new thread. Yeah, let's create it. New thread. We should provide the runnable. Let's name it. It will be providers, just the first one, and we should fetch rate. Okay, so we created thread. What we can do, we should run it, and we can call the method start. Just one small note, we can find another method which is named run, but it will not run your thread in a new thread. It will be called in the same thread, and it will not parallel your execution. So, okay, we have different things like we created thread, and we can start it. And yeah, let's do it for all our providers. So we can use the same stream. We can start new thread here, like for each provider.
Yeah.
Yes, that probably will be changed a bit. Yes, it's another computer.
Could you try again with fonts?
Okay, let me.
A little bit more.
So yeah, where should I go?
I think if you just double shift for any comments, you will find a font increasing. Yeah, increase font size. Yeah, here. And okay, you need to do it again. a little bit more again, I think.
Okay.
Try double shift again and increase the font again.
What happened?
Oh,
Does it work?
I think so. It's better. Maybe one more, just one more time.
It will be a bit more complicated for me. Sorry. Yeah, let's leave it.
Just for
Okay.
your information, there's another way. You can go to settings, editor, and then general. There is a change font size with CTRL plus mouse wheel option, and then you can control and
Yeah, the problem, I don't have any mouse.
oh, sorry.
Yeah, okay. So what we can do there, yeah, let's continue our coding part. We can create threads, provide the provider, which will collect the rate from some implementation. And okay, what we should do, we should collect this data. So we created threads. We should introduce some local variable. Let's name it tasks. And yeah, so we started our thread, and how can we provide the data from it? So each thread will not return any data, and we can work with just base concurrent version of collection.
Yeah, maybe you can try presentation mode as suggested in the chat. You also can. So it says that if you go to view, and then to appearance.
Okay, it's here.
And then appearance, and then intro presentation mode. Yeah, I think that's.
Yeah, the problem, I don't have any other logic here. Yeah, okay, let's try. So I will switch sometimes.
Okay, thank you.
We don't have any command to switch. Okay, so what we can do, we can create some collection. It will be synchronized like concurrent link deck. And we will use rates here. So when each thread started, what we can do, we can provide rates as a result from it. Okay, and in the result, we can just return our rates. Yeah, the problem, I don't have any mapping as I use. Okay, sorry. I will move back. Yeah, just a tricky action. Let's create some test for it. Like we created collection, we run our threads, and we collected some data inside into this collection, and we'll return it in the end. So let's just
use. Yeah, why did it use?
Don't say anything, please. Let's wait.
Okay.
Yeah, so we have base threads rates collector test. We have the same logic, but rates collector should be base thread rates collector. Yeah. Okay, let's run the first test. It's just collecting data and checking that we fetched all of them. But what do we have? We have our correction empty. Yeah, what's the problem? The problem is inside we implemented our implemented logic. We run our threads, but we didn't wait for any results from it. For that reason, we should use another method, join, which is blocking the whole execution and wait for thread finishing. Oh yeah, and it should be covered by try and catch. Okay, let's put it here. Okay, let's run this test as well. Wow, what happened? We didn't start it, sorry. Yeah, that's the problem. Okay, let's remove the previous code. Check that it's not working. We started all our threads. But okay, if we add some sleep here, still not be working. Let's put here. Let's run. Yeah, it's empty. And if we add some logic about waiting for the result of each thread, it will collect all the data, even if it takes some time. Yeah, just return another one, but yeah, probably just okay. The problem is in the order, yeah. And currently it will be working. So, okay, we introduced some usage of threads, joining them and waiting for results, and we were able to collect all the data. But what if one execution flow is just taking a lot of time? So do we want to block our user and return all of thousands of providers rates, or we can just return the fastest, like we are able to create the best rate in the market just based on like top 10 providers. Let's improve this second test, which is about in sequential mode. We were waiting for the final results of each one, but here we should yeah, just wait for result which is taken less time than our time limit. Let's say the first provider will return the result in 1 second, and it will not be collected as we want to provide some wait time to our service. So verify methods will check that both providers will be called, but in the result we are collecting only the fastest one. So we should update our logic. We have here, we don't have any constructor. Let's have some wait time. Okay. Let's provide this data to this. So let's imagine we have a timeout for all our providers, like half of the second. And this test should return only which are on the time. Let's check it. It shouldn't work. yeah, it's still collecting all the data. Yeah, just actual results, but we wanted to find only one. And let's implement some timeout. So what do we have? We have just base join method, and we have some algorithm version, which is about providing some timeout there. So let's provide it here. Okay, we should provide just milliseconds. So we have wait time 2 millis. And let's check it. We run the same test, and yeah, we collected only one rate, and the first provider, which is taken more time than we have, just was not collected. Yeah, I have one more thing for implementation. We can use not base thread join method. We can use another thing, which is just specific for multithreading. It's named countdown ledge. It works like we can set up it for waiting like n threads, in our case 2, and we should provide into different tasks, and then we just can block on it, like await for all 2 tasks should be executed. And yeah, the main thing is all tasks will be executed in parallel. When it finished, we can count down the ledge. Like we have a limit of 2, and we should unblock the whole next part when we reach a 0 value. And in this case, we should just count down after our task finished. So let's create it. Like we have, how many requests do we have? It's provider size. In the result, we should, yeah, let's remove this timeout. And in the result, we should decrease the required number of awaiting. And finally, instead of this method of join on each thread, we can use this ledge and just wait. So we can just wait for the whole result just until it will be executed, or we can wait for some timeout. Yeah, let's put it here as well. Wait, how it should be provided. Yeah. But it still require catching some exception. Oh, no. Okay, let's put it here. Okay, this await returns just a Boolean. And we can await for some data, and in the result, we still need to return our result back, which is rates collection. So let's check how it works right now. We will run the same tests. Let's run the whole scope. Yeah, we just found currently how we can use base threads in our code, and how we can join for the results of them via some additional stuff like countdown ledge, which is blocking the whole results, or we can wait on each thread. We can compare these different things, like let's imagine in the first thing, when we introduced awaiting time on each task, it can be executed like half of the second on each thread. So in case we have 4 threads and we have total timeout of 1 second, and each request just takes half of the second, in the result, total time will be 2 seconds. And it should be blocked, but it will not work in this case. But countdown ledge will take a timeout for the whole for all our threads together. That's the main difference in these 2 approaches. So yeah, Java threads are mapped to the system level threads, as I said before, and yeah, the operating system resources will be split between them. But if we create threads uncontrollably, for instance, for each our new task, we can run out of our resources. And yeah, also any creation just takes a lot of time. And yeah, I would say just base creation of threads is a bit overcomplicated for us. So let's find any better solution. For that reason, we can find the next part of our presentation, thread pools. So thread pools is a pool of threads that can be reused to execute tasks. And yeah, we can say that each thread from this pool may execute more than one task. Not at the same time, just in the total period. The main purpose of a thread pool is to reduce overhead of creating new threads, as it costs a lot of time and time for garbage collection and any other related things. And also these pools provide us a mechanism of reusing idle threads. So in case we can submit more and more tasks, we can reuse the previous threads, which are just waiting for a future work. Also, when a task is submitted to a thread pool, it's assigned to an available thread for execution, but we can find that threads currently are unavailable. They are working on different tasks. So it will be put into a queue, and then all the tasks will collect some, all the tasks will be collected by available threads in future. So in the result, this can improve the performance of the application by reducing the overhead of thread creation and its destruction as well. Yeah, when we use different thread pools, we write our concurrent code in the form of parallel tasks and submit them for execution to an instance of thread pool. This instance controls several reuse threads for re-executing our tasks. The pattern allows us to control the number of threads we allow to create and control by our system. And also we can use some specific thread pools like scheduled, and we can provide some scheduled tasks which will be executed in some time periods. Okay, so let's move to the coding part. Yeah, I just check out to another commit. I can remove all the things we implemented as it's already covered by some implementation. I will share my repository and you can look at it later at all steps we are going today through. So let's remove our code. And we are going to implement another one, which is about Executor service. So let's think about the same approach. We can use some threads inside. It will be paralleled execution, and we have some timeout on our execution. So what we can do, we should just use Executor service. It's a base interface in Java, which is providing some behavior which we introduced before, like a thread pool. Let's remove all things from this one. Let's remove just everything. So let's create Executor service. It will be a part of our service. It will come to us through constructor. Okay. So each executor service can be implemented by different ways. We will use a fixed thread pool, like we have inside a pool of n thread size. So what we can do, we can call method submit. We should provide some task, like we have. We should submit some data and collect it. Like we have our providers. Okay, let's get just 0, and we can get rate for symbol. What do we have in the result? Let's check what is the type of result from submit action of executor service. It's a future. So on each submit request, executor service returns an object future class, which represents a future result of an asynchronous execution. This result eventually appear in the future after the processing is completed. So yeah, we can use some methods like blocking method get awaiting for the result. We have task, and we can await for the result get. And this method will return us the result. So let's move it to stream as well. We have providers. So we have this logic. And yeah, this approach is a bit better. We don't need to create each time any thread. We can collect all tasks and then just wait for the results. It can be done like this. So we have tasks, and we should just collect all the data from them. And let's try catch it. That's how it should be working. Also, I have a bit updated our test for parallel execution. It's parameterized, and we can add our new implementations into these arguments and test all of them. So let's add our current implementation of which is based on executor service. Yeah, and we should provide some executor service. Let's create it. So to create some base implementation of executor service, you can use class executors. There we can find new single thread, which is just a queue, which will be executed in a sequential way, but all the tasks can be stored there and will be executed one by one. Or we can use just new fixed thread pool. Let's put it with 2 threads, like we have only 2 providers. And we can provide this executor service here. Oh. Okay, I should make it static. And yeah, let's check it. Okay, so what do we have? We have first test, which is just about collecting data in parallel way, just working, and it doesn't work for timeout. So let's improve it. What can we do? We can add some timeout. So each get method also can get some timeout values. it will be working the same as we had in case of just threads and joins. So in case we have 4 requests which are taken for half of the seconds, they will not lead us to the total timeout. But yeah, let's imagine we are okay with it. Also, when we call get with some timeout inside, we should add timeout exception handling. Let's just handle it as a timeout, like throw an exception. Or we can work by another way. We can collect some data as well, and we can just keep it probably. Let's say from this we can return optional with value, or we can return empty from this method and then just flat map to final collection. So it's just a case, and let's our tests. Let's not spend some time on it right now. Okay, checking tests. Why it's not working? Yeah, okay. We just throw an exception. Yes, that's right. So yeah, let's return result as an optional. So from this one, we will return optional empty. We have stream of optionals, but we should return real rates, and let's flat map it by optional stream. Okay, let's run it. Yes, that's working. So I would say it's a really more fancy way to implement any parallelism in comparison with just base threads creation. And it's also about avoiding a lot of time for consuming any garbage collection. Yeah, also we can find any other method, like if we have future, we can cancel the task, like this one. Let me just show it. And we can say a Boolean flag, like, do we want to interrupt already running task or just stop only, which is just queued and not started to be executed. Yeah, but we don't have any guarantees that it will be canceled and will not provide any result. So it will be just scheduled and probably will be canceled by the thread. Okay. And yeah, I assume we are done with this part. And let's move to the next part, which is related to the same topic, which is about thread pool implementations. And there are a few base implementations of Executor service. Yes, the first one, single thread executor, we already discussed it. It's like a single worker thread, which is working with just a pool of tasks and executing them one by one. Also, we have fixed thread pool. So the main difference, it's like we have a pool of threads. So we can execute some data in parallel or concurrent. It depends on your processor. So at any point at most n threads, threads will be actively processing tasks. And yeah, if additional tasks are submitted, they will be stored in queue and then extracted by free threads. Yeah, and the main thing about this is all threads which are created for this fixed thread pool will be existing until it's explicitly shut down by manual request to Executor service to shut down itself. The next thing is about cache thread pool. How does it work? It creates a new threads as needed. So when we submit some task, it checks how many threads do we have and how many available threads which are not working on any task. If we don't have any available thread, we will create another one. So it can be growing more and more. And in case we have some throughput coming to the mid of the day, just coming a lot, like we have a really big growth, we can provide this executor service, which will be increased, and it will be able to execute all tasks without any delays. And how it will be diminished in size. All threads by default will be removed from the thread pool if they are not using for more than 1 minute. Let's compare cache thread pool and fixed thread pool. I would suggest using a cache thread pool when you execute many short-lived asynchronous tasks. Yeah, that's just from my experience. And a fixed thread pool, if you have a huge number of long running tasks and you're not sure what is the time of execution, it's not it's unpredictable. For instance, some requests for data and input-output tasks. So in that case, we should not block any threads and create more and more in case they are blocked by any long-running task. And the last implementation is not the last, like the fourth is a scheduled thread pool. As I said already, we can create some scheduled thread pool. So we can schedule commands to run after a given delay or probably just to be executed periodically. Or it can also just submit one task for right now as a base thread pool. It can be useful when you need to set up any background process controlling some stuff in your app. For example, it could be a process of fetching some data, collecting it to the cache before the value is expired. Yeah, and the last one is about work stealing pool. So yeah, we have some paradigm. It's a fork join framework in Java. This framework solves a common problem of spawning multiple tasks in recursive algorithms. In practice, this means this framework firstly forks, like recursively breaks all tasks into smaller independent subtasks and just do it until they are simple to be executed to run asynchronously. And after all results, all tasks provided, they are executed in parallel way, concurrent. And we have another part which is named like join part. And all results of all subtasks should be recursively joined into a single result and return as a initial request, what we wanted to get. But we can find some additional case like task returning void, and this program will just wait for finishing of the task without any collection into one single result, any data, as we don't have data. It's void. What's about work stealing? How does it work? Worker threads can execute only one task at a time. And one of the benefits of the fork join framework in Java is that it's implementing work stealing. It doesn't create any new thread for each task. Instead of it, each thread has its own deck with tasks. So each thread can extract from the first part of it new task and execute them. And in case we have any thread which is available and no task in its deck, we can steal some data from the tail of any other thread. So this architecture is vital for balancing the thread workload, and it helps to execute some stuff with a parallelism. And yeah, using inside work stealing algorithm. Yeah, this thread pool should be used mostly for recursive tasks. So we have some things there, which is named recursive task or recursive action. And we can submit it to fork join pool. So we should provide it with the logic of splitting to two different ways. So if the task is splittable and it's big enough, we should split it into small and provide it as a result of this function, which should be overridden. Or in case we reach the minimum size of the task, we can just execute it. That's how it works inside. Also one note, it's a big note, the JVM by default uses fork join pool as a base thread pool in the whole application. For instance, when you use a parallel stream, so we use just base stream, but we can put it into parallel work. And under the hood, you will find that it works with a common JVM thread pool, which is a fork join pool. But one additional note, just be careful with using base parallel stream. Yeah, it works well, but in case you are working with the same thread pool in all parts of your code, this old task can slow down your app in unexpected places. It's like it can block everything, like you can place some long task with others, which is a smaller one, and smaller task will be blocked by the long one. So the whole app will be blocked. Okay, and now we can go to use this for join pool and parallel streams. Let's create another one rates collector. Let's name it parallel stream rates collector. So what do we have? Let's leave here executor service. Probably it will be helpful a bit later. But yeah, we can remove just direct executor calls. We can avoid any collection and get. So we can replace base stream by parallel stream. And just use a base logic like in a sequential mode, but it will be parallel as it's a parallel stream. So we have provider, let's name it P, provider, rate for symbol. So we have these rates and we can return it. Yeah, it should work. Let's test it. We should add it inside this logic. Parallel rates executor, no, parallel stream rates collector. Yeah, that's true. So let's run it. Yeah, and it's working in a parallel, like just a few milliseconds. But it's still not providing any timeout solution as we implemented before. So what we can do, we can firstly, let's dive into the logic how to use another thread pool. As I said, we are not able to use the same common fork join pool from entire system, from entire JVM in all places. So we should execute different tasks in different executor services. So we have one, and we can use it. How to submit all our tasks? We can. Yeah, it will be looking really strange, but it works. So we have executor service. We can submit a task there. And we just provide our parallel stream. What is the result value? It will be future with list of rates. And then we can return these values back. But we still need to wait, as it's a future. Yeah. Okay, this should work. Let's check it. It will be working with the same approach, but it's just an option to provide our custom executor service. Yeah, but one problem, we still don't have any timeout logic. So how to produce it? We can just use the same future get with timeout, like we have a wait time. We should handle a timeout exception. And okay, what can we expect here? In case we just run all tasks inside one future, it will wait and it will be broken, and we will not return anything from this part. Let's check it. So in case of timeout test, we will find just empty results. No, not empty, just timeout. So we don't have any results. And we are not able to find any data here. So we don't have any tasks, and we can just return empty collection. But one more way, we can provide collection, especially for this one. It should be rate collection. And when we got rate, then we can put it to the rates collection. Oh. And also we should return it. So how does it work? In case of we are getting all results until the total timeout, they all finished, we will return just rates collected from this parallel stream, from this task, from this future. But in case we got timeout, we can go to return just rates. And yeah, we will return only that where we collected some data. Let's check it. Yeah, that works. All our tests are green. And yes, we are finished with this part. And yeah, let's move to the next one, which is about CompletableFuture. Okay, we already learned about threads, thread pools in Java, just some customized thread pools and how to use it. But what if we have a situation when we should run our task in a series of steps? Or even if we need to handle some errors that might occur during one of the steps. In Java 8, introduced another version of class providing asynchronous computation results, CompletableFuture. It's some part of, yeah, it implements future, so we can use it as a base future to start and to wait for the result. But it also implements the completion stage interface that defines the contract for asynchronous computation step. And through it, we can combine different steps, build some chain and execute it one by one. So as I said, we can use it as a base future. Another option is to create already completed CompletableFuture object, or we have really useful approach, like we can create an empty CompletableFuture and then wait some time and complete it by the result. So it will not be completed until we provide any result to it. How can we use it? I have a good example from my experience. So let's imagine we have some synchronous request from the user, and timeout of the user app is like 5 seconds. Synchronous execution means we should wait for the response from the system. We got this request, but we have all our providers which are not returning results on the first call. So it's working like asynchronous calls, and we should send request. We don't have any response from providers, and we have any other subscription, other part of code which is listening for events or just in point where providers will come to us with some response. So how can we implement it? Just to return result into user thread in the same request. We can on user request create CompletableFuture, which is empty. We can block the whole request of the user, like call get method, until it will be unblocked with some timeout, for instance, for 5 seconds, as we already discussed. And yeah, we can send some request to execute this task. And we should store our CompletableFuture, which should be completed later. So in other part of code, when we got some response from that provider, we can find that stored CompletableFuture, which is empty right now. We can call method complete, provide some result, and method get on the thread, which is blocking the whole request of the user, will be unblocked, like, yeah, that's just finished, and we can provide the user the result. So it will be an implementation of synchronous with asynchronous calls inside it. So it's really a useful feature. And the most popular way to use CompletableFuture is to start it and apply further steps step by step, or handle errors and timeouts on it. We have two main methods to start a concurrent execution of our code, which is not here. It's supply sync and run async. So it starts a new thread working with some task. Run async just not returning any value. Then we can apply further steps, such as then supply and then compose. They have different arguments, as we can see, and they can be used to apply different steps for the previous results. Supply just uses the previous result, and compose can be used for the chain when you have different methods returning CompletableFuture. So it works like just a base feature of yeah. The difference between then supply and then compose is just the same as in map and flat map in streams. Also, we can combine different futures by two methods, any off and all off, which is static. So all off will wait for all CompletableFutures are finished, and any off just wait for the first, like not first which was put firstly, but just first finished. One more useful method is about handling errors coming from the execution from any step. So we can use method handle. There we have two parameters, like the result and throwable object. Either first or second is present, so we can check that result is empty. So we should find throwable and just handle it somehow, and not throw it into any other chain. So just exit the whole execution. And also we want to restrict our time for execution, and we can process all chains with a timeout. With a method all timeout, we can provide some values there. In the result, we can find thrown timeout exception, and then we can handle it by handle method. And yeah, let's move to coding. Let's create one more implementation of rates collector. CompletableFuture. Let's leave Executor service here as well. Yeah, as we saw, we are not able to provide any Executor service to parallel streams. So we should run it like just an additional task, which is getting a parallel stream inside, and it will be executed in parallel. But CompletableFuture can be executed by the following way. So we have CompletableFuture. We can run it. So we can provide something there. And also we can provide Executor service here. So it will be executed by this REPL. So it's a more modern way, and it's really nice. So what we can do, we can do like use the same providers, stream, start this logic. So in the result, we have our tasks. What is the type of these tasks? It's a, okay. It's a list of completable future. So it's not just a future, and each completable future can be executed in a chain. We don't need it right now, but I can show you how to create it. So we can use then apply. Yeah, we also have some methods with runnable or consumer just to use this value and don't provide it to next result. Like then what accept or then run probably. Yeah. But we need to use it as a chain with a result value. So it will be working like previous step value will be going through all steps. Yeah, just will be modified, and only the previous chain will be used. Okay, we have then apply. So let's imagine we have rate here. We can update rate somehow, like update rate, get another one. And in the result, we will find the same thing. Or we can use then compose, and this should be covered by CompletableFuture, like this one. So it should work. But we don't need it, so let's remove it. Okay, what do we have here? We have CompletableFuture tasks, and in case we want to get all the results, we can handle it by let's name it result. We have tasks. We should collect all of them, so we can use CompletableFuture all of, or we can wait for the first one. And the main problem, like, oh, sorry, any of returns a value, just the same object, and all of returns CompletableFuture with void type. So we should extract some data from it. Yeah, and for that reason, we should add some logic how to collect all the data. So we have tasks. What should it get? Array. Okay, we have result. We can wait for it. So we don't have any results, so we need to just call it as a base get, and then return the values. Let's put here just a timeout. Right now, millis. We also should surround it with strike catch. And finally, what we can find, we should provide some data. So we have tasks which we initially created, and we can use it. So the return value will be tasks. We can check that they are done. And also it should not be completed with exception, probably. Yeah, it's completed exceptionally, but we should check that it's not. And finally, we can get the result. As we know that our completable future is already done, as we code get on all of that checks that all tasks are completed, we can use just join method, which will return the value, and we can collect it to the result. Yeah, I assume it should work. Let's add it to our test and check it. Oh yeah, not this one, this one. We don't need to throw any exception on timeout. We just need to collect all the data after it. Let's check it again. Yeah, that works as we expected. This all times just including the time for the timeout, and like we have a timeout of half of the second, and some other time for execution, switch, and context, and other things. Okay, yeah, we finished with some implementations. I also prepared a benchmark for all of our implementations, and let's take a look at it. Just a second. Okay, let me remove all our things created. No, I wanna just roll back. Okay, we are on the master. We have the same implementations here, like what we did right now. And finally, I want to present you rate service benchmark. So it works like we are running all our tasks with different approaches. We have different states, like sequential state, all our implementations. Also, we have some implementation of rate provider, which is named test rate provider. I added here some pre-generated data just to exclude this time for generating data and to be able to test the real results. Also, I added some delay generator, like we have a real vote, and we have some timeouts on request to our external systems, and it will be in test from 2 to 4 milliseconds. Yeah, let me find where is it. Yeah, I just updated it, and let's check the presentation. Oh, sorry. Yeah, so what we have here, as I said, I tested this benchmark with some data pre-generated, Also, we generated delay on each request randomly from 2 to 4 milliseconds. And it was executed on the machine with Intel Core i7 with 12 cores. We can find that all parallel implementations with base approaches from Java core library works similar. And in comparison with sequential execution, it works better around 3.5 times. Yeah, all parallel tests were executed with Executor service or just creating threads with the size of at least 4. So we can find that they were executed like in a true parallel. And just we have question rising question like why we didn't have 4x performance gain. But I assume all questions are to the context switch between different threads, as I tested it on my PC. It was not a server machine, and it's a PC with some different processes in the background. So it's still about some context switching between threads. Yeah. The next part is about synchronization. So we didn't cover it. Yeah, when multiple threads are executing within single application, we can use some different shared memory, and we should use it from different threads. We can use it to communicate and coordinate some activities of different threads. However, we should care about the concurrent access to shared resources, as it can lead to some data corruption or other unexpected behavior. Java provides several mechanisms, such as synchronized methods and blocks. We can just put synchronized word to different paths, like method, static method, or just block of some code. It will be working with a lock on some object, like this object or just the whole class. And it will help us to manage concurrent access and coordination between threads. Also, we can use atomic variables, such as atomic Boolean or atomic integer, for instance. And we can set up, for instance, our own lock based on atomic Boolean. How does it work? We should check our value in while. Like our atomic Boolean will present the value. Is it locked or not? So we should wait until the value is false, like we unlocked, and we can go into this block. Yeah, and when we go to this block, we should set it to true, like it's locked by another one, and anyone else is not able to go to the same logic. And this can be done. This must be done via synchronized block of code, and instead of just synchronized logic, we can use atomic booleans. This object provides us the behavior to create an atomic operation which contains compare and set. Like we compare in while block, we compare until the value is false. We can lock it, and if it's false in compare case, we can set true, like it's locked. And after execution of all our code inside, we can unlock it just setting the false value. So it will be just a base lock based on an atomic Boolean. Next approach is just locks. We should lock before our sensitive block, place into the try finally block. And in the end, as I already said in the previous case, we should unlock ourselves in finally. We can find a few base implementations. The first is reentrant. So what it do, Yeah, it's creating an option to re-enter the same block by the same thread. So we will not be blocked in the same code if it was locked by us. So we can use the same lock in other parts of the same logic. And another approach is a composition of read-write locks. For instance, re-enter and read and write lock. So it contains two locks, and the approach is about we can read from different threads at the same time without any blocking, but we must write only when no other read or write operations are currently executing. Yes, sorry, just a second. Also, we can find other thing, which is about concurrent collections. So we can find a lot of implementations of base Java collections, such as concurrent hash map or blocking queue. But they're blocking and can lock other threads until the first action is performed. And also we can find some non-blocking algorithms, which are based on volatiles, atomics, and other ideas, but we will not dive into it today. Yeah, I also wanted to show you how to use some synchronizations for implementation of different things, but I assume we are not able as our time is finishing. Yeah, Irina, what do you think?
Yeah. So should we ask if anyone have any questions?
No, let me continue and we will finish soon. So yeah, I will say what is the task I wanted to show you. It was about how to use different collections and use it with some logs. For instance, in our case, we have rates providers and we have just a few users collecting rates. But what if our service just becomes really famous and a lot of people just using it? So we can find millions of requests in each minute, as an example. And on each request from a user, it's not really efficient to go to the providers, to each of them. So we can provide some additional storage, which will be a shared memory. We can create some concurrent hash map or cache with expiration for values. And we can set up with help of schedule thread pool, an additional background process, which will collect some different assets rates from different providers and put it into our cache. And we should provide read log for getting data by users. And we should provide write log for updating our cache when we got a new rates from different providers. Yeah, that's what I wanted to say here and show you. But probably, yeah, I don't have this commit, but I can add it and you can check it later in the repository. And the last thing is just about what do we have else. If you want to find any other solution to build a concurrent and distributed system, which was not mentioned by me today, as it's not covered by Java core library, I would suggest you to take a look at the following things. The first one is actors, like Echo Actors. It's an open source library, which is based on actors model, like each actor represents an independent computation, which own its own state and business logic as well. They interact only through events, asynchronous messages, events, and never can be called via direct methods. It can create other actors and provide some task for them via messages. And this entire system is organized as a tree-like hierarchy. The second is RxJava, reactive Java, which is a library which helps to consume sequences of data. It combines functional programming with avoiding shared state, mutable data, and side effects by using pure functions. And another approach is reactive programming, which is based on reactive Java, which is reactive Java based on. Yeah, sorry. And reactive programming is about the synchronous programming paradigm, which is about working with data streams and propagation change through it. And the last one, which is a bit more up to date, it's about a new feature in Java. It's coming from Java 19. It's a virtual threads. So as we remember, a base thread is managed and scheduled by the operating system, while a virtual thread is managed by our virtual machine, by our system. So the allocation of virtual thread does not cost so many time and resources, as it doesn't call any system call of the operating system to create a new kernel thread. And it's free for the, it's free of the any context switching between threads. So we don't need to switch context on real processes in a processor. So we can just move data and operate by these virtual threads by the system, by the framework. So we can say these virtual threads are more lightweight threads with better performance. I tested a bit and yeah, I was surprised. And you can try it by upgrading your Java version to 19 preview. And yeah, of course, you can find something else, but let's leave a chance for you to look for it. So yeah, my presentation and some part of coding part is finished. Thank you everyone for your attention, and let's move to the questions.
Thank you so much. And yeah, if anyone have any questions.
Can I stop presentation share?
Yeah, sure.
Mm-hmm. Yeah, I need to find the button for it. Don't see it. Lina, can you please stop it somehow? Oh yeah, thanks.
Like this. Yeah, okay. Yeah, I see some comments. Thank you for your knowledge and thank you for the session. And it was amazing. I got many things to research after this meeting, as I'm pretty new to Java and parallelism and concurrency. And can we have an access to the recording and rewatch it again? Yeah, sure, we will have it. And Valerii, will you share with us this amazing repository?
Yeah, of course. Okay, let me find it.
And I will stop recording right now.